Let's use the multiply-divide node we just learned about to do a simple exercise. This should help us better understand this node. So we can see in my scene there are some gears. We need to rotate this controller to create an automated rotation connection for all the gears. Let's do this together. Let's open the scene file. Here we can see I have a small circle as a controller. It only has z-axis rotation. And we also have some gear models in our scene. Because this example is just to help us understand the specific node, to save time, we'll just connect directly to the model's transform node. We won't bother creating corresponding groups for this rig, and then constraining our model's group. This will save us some time. Okay, let's take a look. First, a very simple one. The controller and this innermost small gear must rotate together. So here, let's put them both in the node editor. Add them in. And let's connect their z-axis rotation together. Okay, this way you see, when I rotate, it will rotate along with it. Next, we need to drive these three gray gears to rotate in the opposite direction. The rotation formula between gears, if the gear spacing between these two gears is the same, which is the case for all our gears here, then it's the number of teeth of the driver gear divided by the number of teeth of the driven gear. We can also see by eye that our two gears are exactly the same. So their rotation ratio should be 1. But because they are in an opposite direction, it should be -1. So here we create a multiply-divide node. And don't forget to name it. Let's call it gear inner. And here we'll also use the z-axis rotation to control it. Why? Because our controller's z rotation is exactly the same as this gear's z rotation. So there's no need to pass it to this gear first and then control the multiply-divide node. We can save a step and just connect it directly. And we mentioned it should be -1. So let's just pick a gear and try it out. Let's pick this 0, 2. And let's connect its output x to this rotate z. Now let's see. Here is input 1x and input 2x. They are multiplied by -1. And this is connected to rotate z. Let's check the result. We can see they have this interlocking effect. So let's connect the other two as well. Here we'll use the multiply-divide node's output x for all of them. Connect them all to rotate z. This way, let's check the result. Let's rotate it and we'll see all the gears have this interlocking effect. Finally, let's see how we do this outermost one. For this outermost one, it's the same gear formula we just mentioned. It's the driver gear's tooth count divided by the driven gear's tooth count. I've counted for us, the driver gear has 12 teeth. And the driven one here has 36, so it's 12 divided by 36. That's a 1-to-3 ratio. Let's create another multiply-divide node. We'll call this one outer. And same thing, use the controller's z rotation to connect to its input 1x. Here, let's change this to divide, and divide by 3. Then we'll connect it to this model. Connect it to its rotate z. Now let's take a look. We find it's moving in the exact opposite direction. So what do? Very simple. We'll change this to -3. This way, look, all the gears are now interlocking. At this point, don't forget to clear the node editor. Then close the node editor. And our little gear rigging exercise is done.